Welcome back to our class and good morning. So you can hear me, right? You can hear me clearly?
Yes, John.
Okay, good. Good to hear from you, Saku. All right, so Kadim is here actually, but we need Zoom also. Even you are on site, but we need Zoom to see my computer and also to see the slide. Susmita is here. Supawat is here. Supawat is not here. Susmita is not here. Vishida here in this room. Okay, all right. Welcome for both online on site. So yesterday I sent you to the link of my record video, right? So yeah, hopefully for the yesterday video you finished that already, right? Okay, and for the other video I sent this morning, have you had a chance to watch it? Not yet.
No, it's not completed.
Okay, so Kadim, please turn off your microphone. Please turn off your microphone. Okay, everyone who was online on site, please turn off microphone. It will bounce. Yeah. Okay. It's okay. So you can take time, right? So yeah. Actually, that's another one type of problem. I think it's good to introduce you with that type of problem. Well, for the morning video, the video I gave you this morning, it involved network problem. Yeah, how to minimize the cost of the total flow of the network, and also you can apply that in for the management of the data in the network. Also, you can apply that idea. I mean that idea of the formulation of the network problem on the maybe supply chain or distribution, something like that. Let me show you again about that problem. Okay, you can see my screen, right? Well, for this morning, I sent you the video, and that video involves the not factory planning. Factory planning is on the yesterday video. This morning video involves curve fitting. Okay, we deal with curve fitting in different several formulation where we try to minimize the deviation, summation of absolute deviation, and also we minimize the maximum deviation of all the error. Minimize the maximum error. Okay, you can take your time to watch that video, right? And of course, if you have problem on that, you can later ask me. Also, I give you the example of transshipment problem. For transshipment problem, let's say that we have multiple source and sink. For example, in this case, in this problem, we have multiple source. S1 to S1, S2, S3. Also, we have multiple sink at P1, P2, P3, P4, P5. you can think that, well, for example, we have supplier 1, supplier 2, supplier 3, and we have from each supplier, we have to distribute our product. Yeah. Okay. 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 All right. I just noticed the technical problem again. So yeah, interesting that I have to put the earphone all the time then. So okay, so I have to select different external speaker then. Okay, good. So, well, for the transshipment problem, we have multiple source and multiple sink, right? For example, we have source S1, S2, S3. Yeah, then sorry that I also have to adapt because, you know, once I use earphone, it's very difficult to hear my voice, so I have to control the level. All right. Yeah, difficult, you know. Yeah, control without feedback. All right, so well, in this case, for example, we have S1, S2, S3 as our source, and we have T1 to T5 as our sink. So we plan to ship our product from each supplier to customer. Also, well, we can send the product or commodity to other sources first. For example, send from S1 to S2 first, and then yeah, later we send from S2 to our customer. Yeah, this is possible. All right, you can see the detail how we can formulate this problem into optimization problem in the video. Yeah, I did that already. And actually, this problem is very similar to minimum cost flow. For minimum cost flow, we have source and sink, and also we have a intermediate node. From here, you see that we have two sources, right? We have node 0 and node 1 as our sources. And we have node 5, 6, 7 as our sinks. Yeah, and we have middle layer in between. So we have to decide to ship our product through the network. And you see that each route has its own cost. So yeah, it has its own cost. So well, you see that if we ship through the route from, for example, from node 2 to node 5, it costs 5 per unit of the product. And also, well, different, yeah, alternatively, if we ship our product from this route, I mean, from nodes 2 to node 4, and then, well, node 4 to node 5, of course, we can send our product from 2 to 5, but in different routes, and it costs different, yeah, cost. The cost will be different, of course, and the objective in this case is to, to find the minimum cost. Okay, I mean the total cost. You can, yeah, of course, you see that it's a kind of network, so you can apply this type of problem to manage the data sent through the I mean network. For example, for internet, right? So you have multiple nodes, and you have to decide which route is better to send your data through. All right, and to balance the load for the node. Also, you can apply this in the supply chain. You can have a multiple source and multiple customer, of course, and also, yeah, multiple. You can decide the location for the storage, where to place the storage, and then, well, and the total cost will be minimum. Okay. or it can be, yeah, in case of you want to establish the new supply chain, of course you can do that, or even inside, I mean inside in plant, I mean in the process, in, yeah, you can design the distribution of your material in your plant, something like that. Okay, so well, the next problem, this one should be, I should finish this one, and I think that, well, we haven't talked about this problem before, but yeah, this time we do that. We do this type of problem. So the next one is, we call it data reconciliation for data. You know, the problem of reconciliation. Do you have any idea on data reconciliation? For data reconciliation, you know that, well, if you have plans, sorry, I have a problem with this. It's easier to write my own. Yeah. So if you have a unit, one unit, and you know that, well, this one is not dynamic. It's you operate this unit at steady state condition. You know, steady state condition, right? What? Yeah, I mean steady state condition for unit A. What does it mean? A should be operate at the same condition, right? So we can expect that no accumulation in unit A for steady state, right? So yeah, unit, I should not use unit A, unit X, because I use the stream A, stream B, stream C already. Okay, so we have a condition of steady state, for example. So we can expect which A to be, what is it, steady state. B must be steady state too, and C must be steady state, because the whole things here are steady state. Okay, but in reality, if you have this kind of unit in industry, in your plant, I'm quite sure that you bring, yeah, flow meter, and you tap your flow meter on the mass flow of A, mass flow of B, mass flow of C. You will not observe anything looks like steady state, right? You will see that, well, the data of A maybe, well, you got some discrete data, right? Yeah, something like that. Or it's better to, yeah, the data something like that. Okay. Also, if you measure B, this is A, right? This is B. You will get another distribution. Okay. Also C, you will get distribution again. But you know that, well, your system is in steady state. If your system is in, yeah, at steady state, and you need some data to represent the flow of A, flow of B, and flow of C, right? What to do? The question is, how can we, yeah, reconcile with these data? So this problem is data reconciliation. You know that if ABC is, well, this unit is steady state. We know from, what is it, material balance that A must be what? A equal B plus C, right? A is B plus C in case of material balance, right? But you know, well, you monitor, you have data and it's distributed because it contains some noise, some variability or whatever it is, right? So if you need some, well, data to represent A, that data must satisfy with this material balance, right? You will have problem if you report anything which is not, satisfy the material balance, right? Because, well, that means it's not steady state. And what else? What else do you want? The data to represent A, represent B, represent C must be, what's it? The first condition is it must satisfy with our material balance condition. And the second thing, what do you want from this data? The data A must be at the maximum likelihood. It must be, what's it? Surrounded by other data you measure, right? Okay. For example, for example, if we neglect this one first, if we don't care about this condition, if I ask you and you don't know the data reconciliation, I ask you, well, find some data to represent, find some point to represent the A data. What are you going to do? We just find the average, right? You find the average. I'm quite sure that people will, you find A bar is the average of A, of all the A data, right? B also, right? You will find the average. C also, right? But if you neglect this condition, what will happen? There's a chance that A bar is not B bar plus C bar, right? Because you don't have any condition to, what is it? To force A, B, C to satisfy your material balance. Okay. Okay, you got the point. So what to do? For data reconciliation, you can, of course, you can formulate it in different way, but we have only two conditions. The first condition is the data must be, what's it? Satisfied with the material balance. And of course, we can put that things in the constraint, right? And the second objective is the A must be, what's it? Close to A bar, right? Or B must be close to B bar, and C, which is our reconciled data, must be close to C bar. You cannot, have in A far away from A bar. B must be also close to B bar, and C must be close to C bar. All right. So from this viewpoint, we can, we're going to formulate our objective optimization problem. We have, let's say, A star. Okay, A star, B star, and C star. A star, B star, C star are our decision variable or reconcile data. Okay, because we want some data to represent. Okay, you can, oh yeah, good. So And what about the condition of A bar and B bar? Very simple one is you find the what is it, summation of absolute error. Summation. I will write not in that one. A bar of A star plus B bar minus B star. Okay, what that is mean is current. Well, we try to minimize the deviation from A bar and A star, deviation from B star and B bar and B star, and C star and C bar. And of course, you know from the data you can find A bar, B bar, and C star, C bar, right? And the other thing is, well, we have a constraint on A star must be B star plus C star, right? Okay. Yeah, and this is the simplest form of data reconciliation problem. You got it? But of course, you can formulate in different way. For example, if you see that, well, a distribution of A, distribution of B, distribution of C are different. I mean, standard deviation is different. Of course, you can divide it by standard deviation of A, right? We can divide it by standard deviation of B and standard deviation of C. Yeah, to make it in a standard, yeah, value. Or you can formulate different way. For example, you can instead of minimize, you can maximize the probability that A star it has a maximum probability in the clouded of A data points, something like that. Okay. But well, those idea I will not cover here because well, it's sophisticated. So you can see from the in research paper on that. All right. So well, then the other thing for data reconciliation, if you want to implement the data reconciliation, first thing you have to make sure that all these things are in steady state. Right? If it's not steady state, it's no reason to formulate this kind of problem because it's not steady state, right? So and well, is it okay to well to apply this thing on dynamic problem? Yeah, the answer is yes, we can do it for dynamic also, but you know, if you know the dynamic of the process, then you don't, well, you must neglect this one, A equal B plus C, because that is the steady state. For dynamic one, you must know the dynamic of it, and then you can formulate it. Okay. The first one, you have to guarantee the steady state, right? At least know the dynamic of this system, and then you can use it. And the second one, well, you know that the data actually, well, contains noise, contain error, contain variability, right? So the data you selected to what's it for the to form the reconciliation problem, you must remove some outlier first. Okay. And of course, for outlier, you have to decide it by yourself. Maybe the data, any data, yeah, located far away, too far away, maybe 2 theta, 3 theta, 2 times of standard deviation, 3 times of the standard deviation. You have to remove them from your data. It's okay, no problem. Okay, you can do that. For example, we have A around here, like in this graph and yeah, in this picture, and we have another point around here. You see that, wow, that point is too far away from the rest, so you can remove it. Okay. Okay, this is application of optimization in data reconciliation. Any question? No? Okay. All right, so now we move to the next one. I mean, well, of course, later you can have, you can use your convenient time to watch the video again. Okay, and if you have any question, you can ask me anytime. Okay, the next one is, I promised to you this morning that, well, today we will we will solve the problem using Excel or MATLAB. Okay, the first one is Excel, but wow, actually yeah, we do it first, and then, wow, I will explain. I believe that you have Excel. You don't have Excel in your, but it's okay. You, yeah, you can bring your notebook here. This one. Huh? This one cannot be used. Ah, okay, okay. All right, so we will start from the very simple one. But just one moment. I check first if I have a solver. Where is solver in my? Okay. All right, so, oh no, this one, I have to share my screen first. Okay, now you see my screen, my Excel. I'm sorry that this one is, yeah, I'm using MacBook, so yeah, sometimes the interface is quite, yeah, sometimes different. So you have to find yourself from Windows. Even you have used different version, of course, the interface may be different. But, well, first of all, we have to check the Excel add-in first, and we need solver add-in. Okay. You can see it on my screen, right? Excel, that, yeah, I tick that solver add-in, and of course, hopefully we can have a solver now. All right, you find the solver in your computer first. Once I have that add-in, in the menu of data, we see that solver. Okay, solver. Okay, you can follow me, right? And those online too, right? You can follow me. Okay. So you see that if you click that solver, wow, you will get a new window. And in that window, you can set objective. Yeah, this one, this set objective. Yeah, and you can select it, right? Which cell it's your objective. This one, it's your objective function. You have to write your objective function there, okay, in this box, in the objective cell, and then you have to set whether you want to minimize or maximize. Okay, you minimize or maximize. All right. Value of mean, yeah, is the extreme case where you fix the value. Then you want the objective value to be exactly at that point, which is a kind of what's it to fix the constraint. Okay, so the next one is by changing variable cells. By changing variable cell means, well, we have to define the cell which are our decision variable there. For example, if you have 4 or 5 decision variables, of course you have to specify that. Okay, and then you select this one, which cell you want to use as your decision variable. And the next one is subject to the constraint. For subject to the constraint, of course, it's empty. It's still empty because we haven't put anything there. So you have to add it, right? And then on the left-hand side, cell reference, you have to select the cell where you write your constraint there. And of course, the constraint is, well, on the left-hand side is a function of your decision variable. Okay. And on, well, and then you select the, what's it? This one, the lower than or equal or greater than whatever it is, in its integer binary, yeah, yeah. And on the right hand side is a constraint. You specify your constraint there. Once you complete that, you click add, okay. But I click cancel first, and you will appear here, okay. And for, yeah, and you see this tick, yeah, make unconstrained variable non-negative. It means, well, your decision variable, all of your decision variable, you tick here, you assume, you set all the decision variable to be positive. You allow only positive number only, okay. And the next one is, well, select a solving method. Here, well, we have only GRG nonlinear simplex, LP, and evolutionary. Okay. For linear programming, of course, you select simplex LP. And for nonlinear, of course, you can use nonlinear, or for global optimization, we can choose evolutionary. Okay. But at first, most of our problem we formulated as linear programming. So, well, we can select simplex linear programming. Okay, and then click solve. Okay. All right. So, well, we will work in, yeah, some problems. Just one moment. I will use some problem as our example from the previous one. Okay, first example here. So okay, we have this problem. You see the problem, right? So we will work this problem. We work on this problem. We maximize 300 x1 plus 260 x2. write down to my iPad first. And then put in Excel. Okay. So now we're back to Excel. All right, we write that what do we have here? We have x1, right? We have x1, x2, x3, x4, right? For that problem. And we also have ys and yu. Okay. We plan to use these cells as our decision variable. And for objective function, objective, you know that, yeah, objective is 300 of x1, right? Plus 260 of x2 plus 220 of x3 plus 180 of x4 minus HYS plus 6 YU. Okay. And for the constraint, we have, yeah, this one is our, we want to minimize it, right? Oh, maximize it, sorry. Maximize it. And for the constraint, what do we have? We have (11) of x1 plus 7 x2 plus 6 x3 plus 5 x4, right? Yeah, correct me if I'm wrong. 700 here. Okay. Okay. And the next one is 4x1 plus 6x2 plus 5x3 plus 4x4. Yeah, this one also lesser than equal 500. And for the next one is 8x5. You see that for the third constraint, we have ys on the right hand side, right? We move that ys from right hand side to the left hand side, then we minus ys here must be lesser than 0. Okay. And the next one is ys must be equal 600. Yeah. No. I mix up in other thing. Just one moment. 7. Oh no, not 5. It must be 8. So then 0. And the last one is yu must be lesser than 650. Yeah. Okay. Finish. Pardon? The problem again. Okay. Okay. I stop sharing this one and share the problems. Yeah. Okay. See the problem now? Okay.เหมือนกัน ย้ายไปด้วย ย้ายไปด้วยฮะ เดี๋ยวนะแป๊บนึงนะ okay, I share this one again so you can see it. All right, so this one, right? This one, right? You agree with this? I move B6, which is YS, to the left hand side. Okay. Okay. Okay, and the next one, you see that I move B7 from the right hand side to the left hand side. You see that? Minus B7. Okay. Is it good now? Okay, so then we can, yeah, enter the solver. And now we have to select the objective. Our objective is here, right? Okay, and then we maximize. Good. And then by changing variable, we can select the variable range. Okay. Yeah, like that. From B2 to B7. And we can have, yeah, constraint to see that we write it very, yeah, systematic. So we can just a moment. Okay, so I select the the left hand side of the constraint, and also select the right relationship and put the right hand side of the constraint here in this box. Okay, and the next one is we make unconstrained variable non-negative. This is important. If of course, if you you can do it by force, by put each constraint to force each decision variable to be positive. You can do it, but it's easier, right? Well, you don't have to put that. You just click the make unconstrained variable non-negative. It's okay. Okay. And of course, this is a linear problem. So we select simplex LP and then we solve it. Okay. Once we solve it, you see that the Excel adjust find the minimum point for you in your worksheet. And of course, you can see that it keeps solver solution, or you can restore original value, anything. Yeah, but we decided to keep the solution solver solution here. Also, the power of Excel, the power of solver is not only solving the problem. Actually, we can have a report on sensitivity. I will show you first about sensitivity analysis, but we will go into detail of the sensitivity report once we learn about linear programming later. We will come back. Okay. At this time, if we click the report and then okay, then you see that we got 2 worksheets on sensitivity report and 1 sheet on answer report. Okay, and on the original worksheet on our problem, we see that we have the optimum value already, and also optimum decision variable. Okay, but you see that no surprise that because we don't have a restriction on the the domain of the decision variable that must be integer, so we allow it to be float, so it becomes some real number like this. X1 is 16.667, something like that, because we solve it as a linear programming, not a mixed integer linear programming. If you want these things, this number to be integer, of course you have to specify that. Okay, and you see that the constraint, the first constraint, where we hit the first constraint, and the second constraint also, and the last constraint. Okay, so if we look at the answer report, you you can see that in objective cell we have final value, which is because we starting from nothing, right, from 0, and then we reach the final value of this one. Also, for variable cell, value of the final value of constraint, our constraint of our decision variable first, and the condition, which is continuous, not integer, right? And also for constraint, the cell value, and also formula we have. And also we have here status binding or non-binding. Binding means the left hand side and right hand side it's equal. Right hand side and left hand side equal. That means that constraint is, what is it? We hit that constraint already. Yeah. And not, we can call it active. The constraint is active. Okay. When the constraint, we hit that constraint, we call it active. But in Excel, it uses binding, okay, to represent active constraint. And of course, for if we hit that constraint, we don't have slack. Okay, no gap between the value to our constraint. But one constraint, yeah, which is not active, not binding, we have the slack variable. Okay, we have value. Slack means, well, how far the value of that point to the constraint. Okay, you can see that from sheet 1 that you see that now the value is 583. Okay, but our constraint is 600, so the slack it's 600 subtract by this value. Okay, 600 subtract by 583 point, yeah, that one. That means, well, we still have 16, that is 16.667 to hit the constraint. Okay, also for sensitivity report, this one is interesting. Oh, well, yeah, I can briefly explain here first, and then, well, later, once we learn about linear programming, we can come back again on this point. For variable cell, you see the x1 to, yeah, x1, x2, x3, x4, ys, yu. The final value, the column of final value is the value that the optimal value obtained from, yeah, our solution in this round. And we have objective coefficient. What is it? Objective coefficient 300, 260, 220, 180 minus 8 minus 6. You know, you can guess what is it? What are they? Yeah. Look at the objective function. You see that coefficient for x1 is 300, right? Coefficient for x2 is 260, yeah, and so on, right? Okay. And allowable increase, allowable decrease means, well, if the objective coefficient now it's 300, right? If you change this number to, wow, increase or decrease, you can change it without affecting your result. If the coefficient increase less than 28, or it decreased less than 71. Okay, what does it mean? Now it's 300, right? So even the coefficient increased to 320, your solution will not change. You can use the same solution, guarantee that your solution will be the same. Okay, what is solution? Solution is x1 is 16.667, yeah, 7, x2 is 50, x3 is 0, x4 is just 33, something like that. Yeah, it will not change. Even the coefficient of the x1 change. Okay, but it can only change in this range, increase 28 or decrease 21. Okay, and for the coefficient of x2, see that, wow, the coefficient is 260, right? And if this coefficient change, of course, it can change to, well, allow to increase to 37. Okay, 37.33 allowed to increase without affecting your solution. Also for decrease, of course, well, this value can be decreased, but in this range. I mean, well, cannot decrease larger than 10.1 196, something like that. Yeah. Other variable also the same. For example, objective coefficient of x3 now 220, but it can be increased a little bit, but for decreasing it can decrease to 1e30. 1e30 means infinity. It can decrease to any value. For example, even you decrease it down to minus infinity, it doesn't affect the result. I mean, result mean the solution, the final value, the optimum value of x1, x2, x3, x4, y, u. But of course, for the minimum value, I mean the objective function, you have to calculate it, okay, based on the what's it, based on the new objective function. Okay, so and what's it, the constraint. Now the constraint. The constraint, we have the right hand side of the constraint. We have, it is, for the first constraint is 700. The second constraint is 500, right? 0, 600, 0, and 650. And again, this value can be decreased or increased. Okay, it depends. Yeah, and it doesn't affect the what's it? Does not affect the. You don't have to solve your problem again. Okay, of course it affects the value, but well, you don't have to solve it if you did have this sensitivity analysis already. So, for example, if the right hand side of the constraint change from 700 to maybe increase by 10 to 710, it will affect the minimum, the maximum value of the objective function by the shadow price. You see the shadow price. 1 unit change of right hand side constraint of this one result in decreasing of the objective function of the maximum objective function by 10.518. Okay, what does it mean? If your the constraint from 700 change by 10, increase by 10, you multiply 10 by the shadow price and then subtract your objective function. Okay, you can get the result immediately without solving, without repeat. You don't have to repeat the problem, solving the problem. Okay. Okay, any question on the Excel? No question. Any question from home? From online?
Yes, sir. I have a question related to the sensitivity report.
Yeah. What is your question? You repeat your question again.
Yes, sir. My question is that in the column shows the allowable increase and allowable decrease. What's these two columns is actually showing that different figures in like allowable increase 28 and allowable decrease 71, and in the same way the other values for x1, x2, x3. I don't understand this
Okay,
column.
all right. Okay, so you mean variable cell, right? Variable cell, right? This one, right? This one, right? 28 and 71, right? And also this, this column, right?
Yes, sir.
Okay, so you can turn on your microphone so we can discuss. Here you see that now objective coefficient is 300 for x1, right? Yeah. And if you see that allowable increase, allowable decrease here, that means, well, even your coefficient, I mean, the coefficient change from 300 increasing to 301, 302, 320 until 328. You don't have to solve your problem again because, well, you will get the same answer. Same answer means, well, the final value or optimum value of this variable will be the same. Okay, x1, well, it must be 16.6667, x2 must be 50, and so on. Okay.
Yes, sir.
Okay, that answer your question, right?
Yes, sir. I got you, sir.
Okay. Okay, thank you. Okay, any more question?
And sir, sensitivity report gives the precise value of the data.
Right. Yeah, for the variable, of course, we consider the change of objective coefficient. And for constraint, we consider the change of the right-hand side of the constraint. We have, from our constraint, you see that we have 700, 500, 0, 600, and 650, right? Yeah. And we consider, while we study if this value change, yeah, increase or decrease, well, how does it affect the solution? Okay, and we see that, well, you don't have to solve the problem again. Yeah. For example, this constraint 700, if this value change maybe by one, okay, by 1 unit, you can, well, immediately calculate the change of your objective function by multiply 1 with shadow price and then subtract with your objective function. Okay, that is.
Yes, sir. And my second question is, sir, when you solving the question on the sheet 1, and then how this sensitivity report appear? I mean,
Your
Excel made it automatically or manually?
Oh, no, it's automatic, but of course you have to select them. Yeah, I click solve, right?
Okay.
On report, you have to select answer and sensitivity report, and then okay.
Okay, sir. Okay.
It will generate that sensitivity report for you. Okay, so how this what is it, sensitivity report affect us? So imagine that, well, we formulate optimization problem to solve the, what is it, how many product we're going to produce, right? Like this one. And you see that in reality, maybe the contribution of the product, each product, to the profit can be changed. For example, well, during this period, maybe from next month, the price of product 1 increase from 300, maybe now it's increased to 320. And you see that you don't have to solve the problem again. You know that, well, the price of product increase, well, then we get the same solution or not, something like that. And what about the constraint? The right hand side of constraint, you see that the right hand side of the constraint usually involve the availability or capacity or maximum capacity of the unit, something like that. You see that? You can see from the report that, well, if you replace this constraint with new one, for example, now capacity is 700, and if you want to increase the profit, you can consider replacing this unit with a bigger one, something like that. Okay, and you can see the bottleneck, which constraint is the bottleneck, by look at the active constraint and look at the the maximum shadow price, because the maximum shadow price means you change that point, you change that right hand side constraint, it has strong effect on the objective function. Okay. พูดใหม่ได้ไหมได้ยิน Okay. That's a good question. Well, this is if the parameter change, only one parameter change, it's okay.
What is the question?
The question is it possible to use this information if our parameter change simultaneously, not only one single parameter, but well, many parameters change at once? Yeah, the answer is no. If your coefficient of x1 change and also coefficient of x2 change at the same time, you have to resolve the problem. Okay. Yeah, only the case that the parameter change, the only single parameter change, you can use this report. Okay, that is the constraint also. Only one parameter at a time. You cannot change 2 or 3 parameters at the same time. You solve the problem again. Okay. And the next one is yeah, we finish Excel. Now we move to MATLAB. I assume that no more question on Excel. So yeah, MATLAB. This one. Let me check if I have MATLAB in my computer. It must be. Okay, I assume that you install MATLAB in your computer already. So normally I use MATLAB. I use Cursor. It is one program which is a kind of interpretation. We call it YALMIP, YALMIP. Okay, I will show you just one moment. Okay, yeah, call it YALMIP, YALMIP. Okay, YALMIP. This one is a kind of interpreter. Yeah, interpreter. You have to download it. YALMIP. Yeah, download YALMIP and install it in MATLAB. Okay, YALMIP copyrighted, owned by Johan Lofberg from Sweden. If you use it, please follow. Yeah, the license. But actually, it's free. But well, if you use it in your research work, please cite their work. All right. So for installation tutorial here, you can download the official version here from GitHub, YALMIP, yeah, and then install it. All right. But well, in my case, I don't download this one. I just use TBX Manager to take care of everything. Let's see, worldwideweb.tbx Manager. Okay, you download this TBX Manager, and then from TBX Manager, Yeah, run the following code. URL write TBX manager. From MATLAB, you do it in MATLAB. Start from MATLAB, right? And yeah, I share my MATLAB first. Yeah, and because I already installed that in my MATLAB, so sorry that I can show, but I cannot, yeah, execute this. I can do it. But yeah, it's okay. URL right. This one, HTTP www.tbxmanager.com/tbxmanager.m and save it as the TBX manager here. Okay. Once you click it, it will download the TBX manager to your computer. And then from here, from TBX manager, you download it. You can run it, TBX manager. TBX manager. Okay. But not finished yet because our purpose is, our objective is to install YAML, right? YAML. So TBX manager install YAML. Okay, in my case, I'm sorry that I already installed it. But if you haven't installed it before, if you type TBX manager install YAML, you can download and install on your computer. And then finally, before you finish everything, you can say save part. Save part. To save all, everything you did. You did some change on the path in the MATLAB. Okay. And now you can, once you finish this, you install YAML. YAML is here, right? If you say YAML test, right? Just a moment. So not this one. Oh, YAML test, sorry. YAML test. If you install it properly, you will see this one. This window. Yeah, this command. Testing of YAML to solve various types of optimization problem. Okay. What you can see on my screen will be different from your screen. Sorry about that, but it's okay. I will tell you why it's different. Because YAML will test the test with different solver. If the solver available in your system are different from mine, you will get, of course, you will get different result here on the right column. Here I have Gurobi. Okay. For Sedumi, it's free software, so you can have Sedumi in your system. But I recommend you to install Gurobi to MATLAB too. Okay, for Gurobi it's a kind of well, I will show you just one moment. It's an external solver. You can download it from gurobi.com, but it's not free software. But Gurobi allow you to use it for 1 year, I think. as an academic, for academic. Yeah, right. This one is Kurobi optimization. You download it from kurobi.com. Download and license. You go to download center to download the optimizer. Okay, and you select academic, right? You put your name, and for email address, you put your academic email address. Okay, and university too. You specify university and other things, right? And access now. All right. For the license, you can have it here. Just one moment. Academic license. From academic license here. Yeah, the same thing. Yeah. You specify your information first, and then well, once you get through to the site, and then they will give you a code to generate the license. But for that one, you need the internet. I mean, provided by university. I mean, university internet, because it will check your IP address. If you do it from home, you have to use VPN to connect to the university network first, and then you can yeah, complete the license. Fine. Okay. So you can, well, take your time reading the, once you install it, you can take your time to read the, what's it, the manual, how to install that one to your computer.
So what is the purpose of these Kurobi and Yalmik in MATLAB?
Yeah, I will tell you. I will tell you.
Okay.
Kurobi is a software. Kurobi can solve various type of problem. For example, LP, linear programming, right? And of course, very simple to solve the linear programming. Also QP, quadratic programming, and SOCP, which is what's second order cone programming. And the most important one is mixed integer programming. Kurobi can solve mixed integer programming very easy. Yeah, install it first. We will do it. Okay, and the purpose of YALMIP is just YALMIP is actually not a solver. YALMIP is kind of parser. Parser means, well, you code your problem in a specific way, and it will translate into into different solver and select the suitable solver to solve that problem. Okay. I will show you this example code of the YALMIP. Okay, we okay, this is the code for our problem on KWOI. I think you remember KWOI. For KWOI, well, we have what's it, T and P, this variable TP, right? Okay, but I think it's better to explain from the first line. the first line clear all. Clear all means, well, we clear all the variable in the system. And then YAML clear. YAML clear means, well, clear all the variable inside YAML. And we have SDP setting. SDP setting of solver Groby means, well, it tells YAML that we're going to use Groby as a solver. Okay. And the next line T SDP var for 1. It means, well, we create T variable T. Of course, it is our decision variable. And this one contains T contains 4 elements, T1, T2, T. The dimension is 4 by 1, right? So it has 4 elements, okay? T1, T2, T3, T2, T4. And we have P, yeah? P is, of course, it's the same thing. We have P1, P2, P3, and P4, okay? T and P are our decision variables. And then we define the price. This is price for each oil. Okay, we define, yeah, other constant. And then we define the objective function. Our objective function is price times P. Yeah, P is our production. So once we define the objective function, you see that because P is our decision variable. So once we times it, objective function, this obj fund is a function of our decision variable already. And this is constraint defined in the YAML. We set the empty set first, constraint just empty set, and then we repeat this line for, well, from I1 to I3. Yeah, Pi plus Ti equal Di plus Ti plus 1. You remember this problem is a kind of multi-period, optimization problem. Okay, once we're done with it, we have P4 plus T4, which must be greater than D4. And at the starting point in the tank, we have 2000 in the tank. Yeah. Okay, we define it. Okay, and then once we define on the constraint and objective function and decision variable, now we solve the problem using this command optimize. Okay, optimize followed by constraint and objective function and option. Okay, we have already defined the constraint. We already defined the objective function. Then this is the OPTS is the option here. SDP setting solver Groby. We define it and pass it through the optimization command, optimize command. And once if this problem can be solved, of course we can see the value, the optimum value of our decision variable P and T. Yeah, also obj fund. Later I will give you this MATLAB code so you can see how we can code it. Okay, but in order to run these codes, you need YAML. And of course, because I choose Groby here, so you need Groby too. But of course, if you delete this line, maybe select active solver, it's okay. You have to define by yourself. All right, so going to run this code. Okay, and it is done. Okay, here we run the code and then successfully solved by Groby, of course. And then the result Yes, value of P is 3,000. Yeah. 12,000, 5,000, 6,000. And for T is 2,000, 0, 4,000, 0. And the last one, value of the objective function is here. Okay. And the problem, let me show you refinery. Maybe, yeah, this one will be good. Refinery. Because I'm not sure whether you remember KW oil or not, but for this one, I think, yeah, you still remember it. Refinery problem. I showed you last week about refinery problem. Remember, we have C1, C2, right? Crude oil 1, crude oil 2. We have to buy, yeah, decide how much we buy it. And also once we got C1, C2, we have to decide how much we send like naphtha to different places, right? Okay. For simple, I write SDP bar x40 by 1. That means our decision variable now is only x1 to 40. But it's very difficult for me to use x1, x2, x3 because I don't know. I cannot hear your question clearly. Run which question? KWI. Yes. You got the same result with me? Yes. And your question is? Yes, it's okay. Yeah, it depends on, it depends on solver you have. The advantage of YAML is even you solve different problem, there be different problem in different type of problem, different. For example, you solve the semi-definite programming, you solve other nonlinear programming. You know that different solvent require different format of code. All right. But if you use YAML, you write the same way. YAML will take care of that. It will, change other thing and pass through and select the suitable solver for you. Of course, you need that solver too. Yeah, but you don't have to write the code specifically for that solver. Yeah. Okay. For this refinery, you see that we define the decision variable and we define the constraint. And then finally, we use the same code, optimize, constraint, and objective function. Okay. We need value x, value objective function, we show it. Okay, then this is our solution. YAML can solve it, successfully solve using Gurobi. Okay, in that case, it's problem 0. Problem 0 means no problem. It's the flag of the result from solving. Okay, and then we got all the results. Okay. Okay, any question on MATLAB and YAML? Okay, I will put YAML code in Line group, and you can download it and use it later. In MATLAB, you maximize. You, yeah, very simple to change from minimize and maximize. For Yao MIP, you see that for Yao MIP first, okay? For Yao MIP, you see that I did not specify minimize or maximize. That means Yao MIP always minimize. And if you want to maximize it, you multiply it with -1. Okay, you put -1 here, so then it will be maximized automatically. Very easy to change from minimize to maximize.
And sir, what would be the exam purpose? Mean you will give the problem and we have to solve on these software.
Oh no. The first part, I think, wow, the exam is on only written in what is it? You have to formulate the objective, the optimization problem. All right, just write on the paper.
Okay,
Write down
sir.
the paper without solving. Okay.
Okay, sir.
Okay, I got one comment from Saku. We do not know how to do coding in MATLAB. Yeah, no one know at the beginning. Okay, so learn it. Very simple. Huh? Pardon? Yeah. What do you mean? Yes, of course, it's linear programming, so you can use Excel to solve it. Okay. I also have the code on Excel. Just one moment. I will show you. No, it's not here. So sorry. but
in
surely,
a chemical plant, sir, in a chemical plant, the process engineers use these softwares to solve the optimization problems. Like we have learned the example of refinery in the last week, and now this problem.
what is your question? Your question is which software?
No, sir. My question is the process engineer use these software in the chemical plant.
It depends on the application. It depends on the application. For example, for refinery planning, people use Excel. Okay, they invest a lot of money on that model, the model in Excel. Okay, and if you work at that department, your job is only solve the model, change the parameters, something like that. And got the it's a solution and send the solution to corresponding department to in order to operate like that way. People use Excel, but actually they can use Excel, but they don't have model on Excel, right? No, they can use MATLAB, but they will not do that because MATLAB costs a lot of money, right? Also, what is it? They have to invest on the new model, on new software. It's not easy. Okay, so they do what they have. And for other application like data reconciliation, yeah, you can do it in Excel or you can do it in MATLAB. But it depends. It depends on the software available in your department. But for
in a simple way, we can do these optimization problem on simply pen and paper.
Right. Yeah. Yes, it is.
Okay, sir. Okay.
And What else do we have? Yeah, no more. Okay. Yeah, any questions? Anything else? Yes? You write down question in the
No, no, I am speaking. Can you hear me?
just a moment.
Okay. Okay. So I just I have like I have seen three differences on the command of optimization. When we did it on Excel, we only optimize the objective function, right? Now here in the coding of refinery, we have optimized both the constraints and objective function as well. And if you can switch back to the KWI example, we optimize objective function, constraints, and decision variable as well. So what if we don't optimize constraints on MATLAB? Will we get a solution? Okay, okay, all right. Ajay, please first consider the command on line number 96. So, yeah.
Yeah.
Here we have optimized both the constraints and
And objective. No,
objective
we,
function.
yeah, because optimization, you need objective function and constraint.
Right.
But the format of YAML, you have to put constraint first. And followed by objective function.
Yeah. Any last example?
Yeah, in KWI, I put the
This is-
option too,
Yeah, yeah, yeah.
right? Well, if you don't have specific option, you don't have to put that option there. All right. That means, well, YAML will select the available and suitable solver for you, and also they will use what is it, default parameter for solving that problem.
So if we don't put, if we only optimize objective function, will we get solution?
You don't have constraint at all?
No, no, we have constraint. Yeah,
Yeah, if you have constraint
yeah, yeah.
and you don't put constraint, of course you got different
Solution.
results, right?
Oh, okay.
Mhm.
Okay, right. Okay.
Yeah,
Got
but
it.
of course, if you don't have constraint, you must, yeah, you have to define that constraint.
Okay. So I'm asking, is it possible for us to get this program so that we can run it ourselves?
Program what? This code?
Yeah, this
Yeah,
code.
And I told you that I will tell you the code.
Okay.
Yeah.
And the video of the lecture.
Yeah. I turn on my microphone. Okay, so any more question? Of course, the first thing you have to install YAML and install Robit first. Okay, and I should show you. Well, I should show you other example. Just one moment of this one. First example. Yeah, this one. You see that it's interesting here. You remember the first problem, our first problem. We did it in Excel. Yes, you can see in Zoom now. It's on that one. Remember this value? 300, 260, 220, 180, minus 8, minus 6, right? It's coefficient of that problem. You see that previously we solved this problem in Excel, but we did not restrict the the distance variable to be integer. Yeah, but this time we solve in MATLAB, we force them to be integer. You see that we use int var x equal int var 61. It means, well, our x contains only integer number. Okay, can be only integer, and it had 6 variables, 6 elements inside that. Okay, and the objective function is, yeah, because we want to maximize, we have to times it, multiply it with -1, because our YAML takes only minimize. Okay, so I multiply with -1 here, -1, and price, this price here, right? And with x. Okay, and the constraint, you remember the constraint? Yeah, I write the constraint here. It's very easy to read. It's straightforward. The first line is, yeah, empty constraint. We start from empty constraint first, as you mentioned. Yeah, about the empty, that, and then we add constraint line by line. And all the variable must be greater than 0, must be positive, and then we solve it. So yeah, optimize constraint, objective function, and option. We solve it now. Okay, and this is our result. Okay, our result. Yeah, our result now, all the optimum decision variables are integer. Now we force them to be integer only. Okay. Now you see the difference in var and SDP var.สุภวัตครับสุภวัตตามทันไหมครับ
ครับอาจารย์
ครับตามทันไหมครับ
ครับตามทันครับ
โอเคครับ Okay, so any more question? Yeah, I think in line. So, one moment. Okay, I put the code. Line assignment problem. Food manufacturer. Knapsack. KWI. Whatever we need. Okay. Okay, you got all the code, right? Hmm? Okay, so, well, you can take your time to, yeah, watch the video and then, well, also study the code. Okay. Any more question from online? No?
No, sir.
Okay. Okay, all right. So, well, we finished for today. Later, well, once I got the video, I will put the video online and send you the link. Okay, bye-bye. Have a good day.